Pa, you want to tell the kids to stay in school?
What's that?
I'm about to start my live video. You want to tell the kids to do well in school?
Yeah, just tell them that.
Tell them to study hard for chemistry, right?
Okay.
What do you want to say to the kids? Tell them study up.
Yep, behave yourself.
Behave yourself. Pa says behave. All right, we are ready to do some chemistry review. Who is ready? So, if you are not ready yet, if you're not in my class, you might not realize what exam we're doing today. We are doing the January 2018 exam. So, hop on to, if you just go Google Regents Chemistry Exams, the whole list of exams will come up for you. Print out the January 18 or just open it up on your computer. So have your phone out with me, your computer with the exam. We're going to go through this entire exam together tonight and get you ready for this Regents. So tomorrow, all of you, no matter whose class you're in, you'll get a nice schedule of all the different Instagram lives that I'm going to do. This is my second night of doing it. All of them are going to be saved. All of them are going to be put on my YouTube channel. So let me write that down for you guys. So if you go on YouTube and you search Nancy Mancuso, you'll see me. And when you see me, go to the playlists. And under playlist, there's one called Chem Review. So go on there. I've been putting all sorts of review videos as well as these Instagram lives. And the goal is to go through as many of these Regents examinations because this is really what's going to get you ready to take the exam. So I'm going to get started. So which statement describes the location of protons and neutrons in an atom? And I am sure you are going to look at this question and go, oh my gosh, every single time they ask us this. Yep. They do. So get used to it and be ready to answer it. So here's my nucleus. What's inside it? Protons and neutrons. What's outside? Electrons. So let's find it. Protons and neutrons are in the nucleus. There it is. All right. Given a list of the atomic model descriptions, which list represents the order of historical development from the earliest to the most recent? So shells, that is going to come at the end. Hard spheres, that's going to come at the beginning. Mostly empty space, that's Rutherford, so that's somewhere in the middle. So I want BCA. Which list represents the classification of the elements? Nitrogen, neon, magnesium, and silicon. All right, and it's given me some answer choices with like metals, metalloids. So you grab your reference table and you see where each one is located. So nitrogen. There it is. It is on the right side of the table. So nitrogen is a nonmetal. Neon. Ooh, neon is way over here. Neon is a noble gas. Magnesium. That's a metal. That's a left side loser way over here. Silicon. All right, that guy is got two sides touching the staircase. So that's a metalloid. So, metalloid. All right, so I want nonmetal, noble gas, metal, metalloid. There it is. All right, in the ground state, all atoms of group 15 have the same number of. So if you're in the same group, you've got the same number of valence electrons. We could go over here to group 15, and everybody in group 15 ends in the number 5. They all have 5 valence. Again, if you're just joining me, I'm doing the January 2018 exam. I'm going question by question. I'm going to go through the whole thing with you. The goal is to do as many of these practice exams as possible before the Regents so that you're ready. All right, what's the chemical formula for ammonium sulfide? So ammonium, weird name. I go to table E. That's where all the polyatomic ions are. And I look up ammonium. There it is, ammonium, NH4. So I write NH4 and I put a plus on it. Sulfide. Sulfide is not a weird name, so it's not on here. If it's not on table E, I'm just talking about sulfur because remember when you end a compound, you end it in "ide." So sulfur over here has got a -2 charge on it. So S with a -2. Now I crisscross. NH4, I need 2 of them with a sulfur. There it is. Which formula is an empirical? So empirical means reduced, and 2 and 4 could be reduced. NH3, can't reduce it anymore. C3H6 could be reduced. 4 and 10 could be reduced. So that's my answer. Chemical properties can be used too. All right, can I use a chemical property to determine the temperature? No. Can I use a chemical property to tell me the density? No. Can I use a chemical property to tell me between two compounds? Yes. I could decide, like, you know what, this compound reacts in water and this one doesn't. Or this one reacts with hydrogen gas and this one doesn't. Or this reacts with an acid and it doesn't. So chemical properties can tell me about two compounds. Neutrons are just neutral particles in the nucleus. You cannot tell those apart by any sort of chemical property. All right, ice, which is solid compound water, is not ionic, because ionic has to have a metal and a nonmetal. Metal and a nonmetal, and it doesn't. Molecular, yes, because that word molecular means covalent. So if I've got a hydrogen and an oxygen, they're both nonmetals, so that's a covalent molecule. It is not a mixture. Water is not a mixture. You could mix things with water, but water by itself is not a mixture. All right, which phrase describes the molecular polarity and distribution of charge of carbon dioxide? So they're asking me about the molecule. So my advice is get out. Oh, sorry. Geez. Okay. All right. So carbon dioxide, draw it out. I've got a carbon. I've got a double bonded O on this side, a double bonded O on this side. So that's looking very symmetrical to me. Symmetrical means no pull. No pull means nonpolar. So I want symmetrical and nonpolar. All right. Next one here. Which element tends not to react? So those snooty elements that don't react with anybody because they're oh so perfect are the noble gases. So group 18, noble gases don't react. Helium is a noble gas. All right. Again, I am on the January 2018 exam. If you Google chemistry regents exams, a whole list of exams will come up. You can choose the January 2018 exam and just have it on the computer to see. All of you that are at Spencerport, you're going to get a list tomorrow of all the exams I'm going to be doing over the next 16 days, 15 days before the regents, so you'll be prepared. All right, which statement describes the changes that occur as oxygen is produced? All right, I want to remember that saying barf, broken, absorbed, released, formed. So what's happening here? I've got an O and an O coming together. So I'm forming a molecule. So I want this. When I form a molecule, I release energy. So energy is absorbed as bonds are broken. I'm not breaking anything. Energy is absorbed as they're formed. No, I want released. Energy is released as they're broken. No, released as they're formed. There it is. Which term represents the strength of attraction an atom has for the electrons in a chemical bond? So an atom has this ability to attract electrons to it. We call that electronegativity. The more electronegative it is, the more it's going to have that polar pull to it. All right, next one. Oh, hey, Patrick. Compared to a 15-gram sample of copper at 25 degrees, a 25-gram sample of copper at 25 has. All right, so it's asking me about 2 samples of copper. They are at the same temperature. The only difference between them is their size. So like I got a little clump of copper here and another clump of copper here. So they're definitely going to have the same density and they're going to have the same properties. They would have a different heat, but it's not asking me about heat. None of these answers refer to heat. So just 2 pieces of copper, one's 15 grams, one's 25 grams. They're going to have the same exact properties. They're going to have the same exact density. All right, which substance can't be broken down by a chemical change? Hey, if you can't break it down, it's on here. It must be an element. If you can't break it down with a chemical change, it's an element. So ammonia is not an element, ethanol is not an element, water is not an element, tungsten is. The kinetic molecular theory states that all particles of an ideal gas, all right, when we're talking about a gas, we're always talking about spreading out because that's what ideal gases want to do. And remember, they bounce around like a little screensaver, constant straight line motion. So collide without transferring energy. You always transfer a little bit of energy when you collide. You can't help it. Ooh, there it is. Random, constant straight line motion. All right, moving on. Which sample of a gas at STP has the same number of molecules as 6 liters of chlorine? If I have 6 liters of this gas, give me any other gas with 6 liters and it's going to be the same number of molecules. So go find the 6 liters. There's your answer. A chemical reaction is most likely to occur when the colliding particles have the proper, all right, remember my high five? You've got to have the right energy and the right orientation to have a good collision. All right, the energy absorbed and the energy released during a chemical reaction are best represented by, all right, a cooling curve is going to look like this. That is not going to show me energy absorbed or released. Heating is just this backwards, so nope. Kinetic energy is just showing me temperature, so that's just like that. Here we go. Potential energy diagram. Potential energy diagrams go like this. Ooh, energy going in, and then here's my product. It shows me how much energy went into this endothermic reaction, so that would definitely show me energy absorbed or released. All right, a catalyst increases the rate of a reaction by. So I love to talk about that story with Marge getting in the middle, making Susie and Bobby collide when they weren't ready for it. So it's all because they provide an alternate pathway, and that alternate pathway reduces the activation energy. They came together so much easier because of that reduced activation energy and the new pathway. If you don't know that story, it's on last night's Instagram, which is now on YouTube. All right, which formula represents an alkyne? All right, if I want to know about an alkyne, I just grab my reference tables and I go over here to table Q and I look up alkyne. Alkyne with a Y is CnH2n minus 2. So, oh, and they're not even making me doing the work. There it is, 2n minus 2. Which process involves the transfer of electrons? So, oxidation is losing electrons, reduction is gaining electrons. I want a redox reaction if I'm talking about electrons. Which change occurs at the anode? All right, first of all, I'm writing anox. I always remember anox and red cat. So oxidation is losing oil. Remember the oil rig? So oxidation is losing, so I want loss of electrons. Which device requires electrical energy? So something that requires electrical energy needs a battery to work. So an electrolytic cell will not work unless you plug it in because it's trying to make